Okay, we're talking about graphical analysis of motion. And all that is basically looking at motion graphs. Can you tell what an object's doing by looking at the distance time graph or the velocity time graph? Or if I give you a description, can you create the distance time graph or velocity time graph? So that's what our goal is for this unit. There are three basic motion graphs that we're going to talk about. A distance, or sometimes it's called a position time graph, a velocity or speed time graph, and an acceleration time graph. A position time graph, which is probably what the proper name should be, but a lot of times I'll call it a distance time graph, shows you where the object is at any moment. A velocity time graph shows you how fast an object's going at any moment. And then acceleration time graph just gives you the acceleration at different times. Let's look at a distance time graph first. This is a distance time graph. And in this distance time graph, we've got an object that's doing this, which means as time goes by, it's getting further and further away, pretty much at a constant rate, because we've got a nice straight line. So this object's moving away at a constant velocity. Now, since it is a nice line, we can take the slope of that line. So the slope of a distance time graph, well, let's see. Slope is change in y over the change in x. So the y is distance, the x is time. So we have distance divided by time. Well, distance divided by time is velocity. So the slope of a distance time graph will give you the velocity of that object. And the steeper the line, the faster it's going. So if this line was steeper, that means that object's going faster than this one. If it's more shallow, that means that object's going slower than this one. The main takeaway is that the distance time graph slope gives you velocity. And the steeper the line, the faster it's going. Okay? So let's take a look at a velocity time graph. Okay? So this is a velocity time graph. Now on this one, we get a nice horizontal line. So that means that this object was whatever this speed is. In this case, we're doing what's called sketching a graph. When you sketch a graph, you're not concerned about how the numbers are plotted, what exactly is the scale on each side. We're just looking for the shape of the graph. Okay? And so in this one, we get a nice flat line. So that tells me that this object was staying at the same speed the entire time. With this is 70 miles per hour, and it stayed at 70 miles per hour the entire time. Now, the slope of this line, again, we can take the slope of a graph. The slope of this one is, well, it's zero because it's a horizontal line. But the slope of a velocity time graph means we have velocity divided by time. Velocity divided by time is acceleration. So the slope of a velocity time graph gives you acceleration. The slope of a distance time graph gives you velocity. Okay? So now for us, in this class, acceleration time graphs are going to be very dull. They basically look like this. Either we're going to get a constant positive acceleration, a constant negative acceleration, or the acceleration is going to be zero. That's the only three options with acceleration time graphs. So that's why we're mostly sticking to distance time graphs and velocity time graphs for most of our content. So I've got three different situations here. Standing still, and we're going to get all three graphs with it. Constant positive velocity, going to get all three graphs with that one. And positive acceleration, and again, do all three motion graphs with it. So an object standing still, what does these look like? Well, if I draw in an example here. So this object stayed at this position. That's basically, here's the origin. You're standing away from the origin and you don't move. You get this line. Well, if we take the slope of a flat line, you get zero. So my velocity is zero. That's supposed to be at zero. I couldn't draw it exactly on that one. And so again, but that's a horizontal line. So the slope of any horizontal line is zero. So the slope of that velocity graph gives us the acceleration, and it's still zero. over here, we've got something moving at a constant positive velocity. So it starts off here and starts moving away at a constant rate. Take the slope of that. Well, it's angled up. So that means the slope's going to be positive. It's a straight line, so the slope's going to be a constant. So that means our velocity is this line right here. Whatever this velocity is, it stayed that velocity the entire time. And that's why it gave us this graph. Slope of this gave us that. The slope of this, well, that's a horizontal line, gives us an acceleration that's 0. That should be at 0. That's as close as I can draw it on this program. Now, if it's accelerating means going faster and faster and faster. So that means that this line is going to get steeper and steeper and steeper. So it starts off shallow and gets steeper. Well, you can't do the slope of a curve without using calculus, but we can get a good estimate. Here it's very shallow. Here it's a little bit steeper. Here it's a little bit steeper. So the velocity is going to get bigger and bigger and bigger. So we get this line here. That's the velocity getting larger and larger and larger, getting faster and faster and faster as time goes by. But if we take the slope of this, well, that's going to be a straight positive line. So that's going to give us our acceleration here. Those are our 3 basic situations, but let's do 3 others. Let's do one where the object's decelerating, moving at a constant velocity. Let me move myself over to the other side. There we go. And one where we're decelerating. So what would these look like if we tried to graph these objects? Well, it will look like this. Here, we've got object going fast, okay, and then it slows down and comes to a stop up here. So what would the velocity graph look like? Well, here it's steep. Here it's not as much. Okay. And here it's a little bit less. So our velocity is going to be big right here. And then as time goes by, it gets less and less steep. So that means the velocity gets slower and slower and slower until it comes to a stop. The acceleration time graph, if we look at this, the slope of this line is negative. So our acceleration is going to be negative. Where it's slowing down, it's losing speed. And so that means the acceleration is going to be less and less and less. Now on this one, constant velocity towards the origin. So we're going to start away from the origin. All these others we started at the origin, but this one we're going to start away from the origin. And we're moving back towards the origin, so we're going back to where the distance is 0. Well, if we take the slope of that line, well, it's negative because it's angled down, and it's a constant because it's a straight line. So we get this line right here. Well, that's supposed to be a horizontal line. So we take the slope of a horizontal line, we get an acceleration of 0. Right through there. This one, decelerating to a stop at the origin. So we start away from the origin, going fast, heading back towards the origin. We're starting to slow. We get slower and slower and slower until we come to a stop down here. So big negative velocity, going less and less and less. So this is our velocity time graph right here. Start with a big negative and get towards 0. So we get a positive acceleration with this because it's angled up. Now this one's kind of confusing. If I'm going back, so if I'm going this way, and I want to speed up, I want my acceleration to be the same direction. But if I'm going this way and I want to slow down, my acceleration needs to be in the opposite direction. So that's why these are backwards. I'm going in a negative direction, but you want to slow me down. So you have to push against me in the positive direction to slow me down. So that's why the acceleration is positive while we're slowing down, because we're moving in the negative direction. So to slow down, I need to be pushed in the positive direction to stop me. Let's look at this one. This one's a little bit more complicated. We got a lot of things going on. And I wonder if I can move myself up here. Oh, I'm making a trip all the way around the place. Okay. So on this one, we got a distance time graph. We've got an object doing this. And we got sectioned off into different sections like O to A A to B, B to C, C to D, D to E, E to F. So you first want to figure out which part of this graph represents an acceleration. If you go back and look at those other graphs, on a distance time graph, if something's accelerating, whether it's speeding up or slowing down, the graph's going to be a curve. Okay. Now, object at rest means that the object's sitting still. So it's staying in the same location for a time. Shows positive uniform velocity. So we're looking for a constant positive velocity. And this one shows greatest velocity in the opposite direction. So take a moment, look at the different sections, see if you can pick out which one or ones match those statements. All right, now let's look at the answers. So, shows acceleration, that's B to C, that's the curved part. We're going faster because it's getting steeper. Shows an object at rest, well, it's at rest between A and B and D and E. That's where it stayed at 30 meters here and 20 meters there for a time. Shows positive uniform velocity. So only place it shows positive velocity is from O to A. That's the only one that's angled up. And shows greater velocity in the opposite direction. Well, moving the opposite direction, we got either C to D or E to F. But it asks for greatest. So the greatest one is E to F because it's the steepest one. Let's look at a velocity time graph. So this is a velocity time graph. Always check the side to see what it is. Again, we got it broken up into sections. A to B, B, C, C, D, E to F, F to G, G to H. Now, it could be a section or it could be a single point. But where is the object stopped? Where is the object having a positive acceleration? And where is it traveling at constant velocity? Now remember, this is a velocity time graph, not a distance time graph. So take a moment, look at those sections, and pick out which one you think, or points, answer those questions. Okay, let's take a look at it now. So the point where its object is stopped is at H. That's the only place where it has zero velocity, is at point H. Shows positive acceleration. Now remember, this is a velocity time graph. So if it's changing, that means it's accelerating. So the only place that has a positive slope is E to F. Then shows the object traveling at constant velocity. Well, in this graph, a flat line means constant velocity. So here, travel at a constant speed of 15. Here, constant speed of probably 6. And here, a constant speed of 25. Actually, that's probably 5 right there. And that's 25. So you've got to pay real close attention about which type of graph you're talking about in order to answer questions about these, whether it's a distance time graph or a velocity time graph. It's very easy to get the two confused. So go back over these and try to find more examples to help you out. Okay? Thank you, and hopefully see you later on.